In this video, we're going to complete the KutaSoftware free worksheet under the Infinite Pre-Calculus section, Function Operations. Now, for numbers 1 through 16, it says to perform the indicated operation. In number 1, we have f of x equals 3x plus 4, and g of x equals negative 2x squared minus 4. And we're finding f plus g of 8. We're going to add these two functions together and plug in 8 for x. So we have 3x plus 4 for f of x, and we're going to be adding that to negative 2x squared minus 4. Now from here, there's two different ways we can approach this problem. We can recognize first that 4 will cancel out with 4 because 4 minus 4 is 0, and then plug in 8, or we could leave the 4 in there, plug in 8, and then simplify. So I'll go ahead and cancel out the 4 because 4 minus 4 is 0. So I'm left with 3x plus negative 2x squared, which is 3x minus 2x squared. Now I'll plug in my 8 for x. So I'll have 3 times 8 minus 2 times 8 squared. 3 times 8 is 24, and we're going to be subtracting 2 times 8 squared, which is 64. 24 minus 2 times 64 is 24 minus 128, which is going to be equal to negative 104. So negative 104 is our solution in number 1. Let's move on to number 2. In number 2, h of n equals negative n cubed minus 2n, and g of n equals negative 2n minus 1. We're to find h over g of negative 4. So h of n is negative n cubed minus 2n, and I'm going to write that h of n over g of n, which is negative 2n minus 1. Now in this case, it's easier just to go ahead and plug in the negative 4 now as opposed to simplifying first. So plugging in the negative 4, so for negative n cubed minus 2n, it'll be negative, or the opposite, of negative 4 cubed minus 2 times negative 4. And then for negative 2n minus 1, g of n, g of negative 4, will have negative 2 times negative 4 minus 1. Negative 4 cubed is negative 64. So we're going to have the opposite of negative 64 minus 2 times negative 4, which is negative 8. But as opposed to subtracting negative 8, I'll add a positive 8, and that's going to be all over negative 2 times negative 4, which is positive 8 minus 1. So the opposite of negative 64 is positive 64, and 64 plus 8 equals 72, and that's going to be all over 8 minus 1, which is 7. So 72 over 7, or 72 divided by 7, is our solution in number 2. Now for number 3, we're going to be multiplying f and g and evaluating that when t is 0. So f of t times g of t is going to be 2t minus 3 times t cubed plus t. Now I'll go ahead and enter in 0. So we'll have 2 times 0 minus 3 times 0 cubed plus 0. But before I go any further, 0 cubed plus 0 is 0, and 0 times any quantity is 0. Therefore, it doesn't matter what 2 times 0 minus 3 is, although it is negative 3. So negative 3 times 0, we know, is 0. So 0 is our solution in number 3. Moving on to number 4, g of n and f of n are given to us, and we're finding g of f of 6. Another way to write this is g of f of 6. So we're going to evaluate the function f at 6 and then plug f of 6 into g. So f of 6 is equal to 6 squared minus 1. 6 squared is equal to 36 minus 1 is equal to 35. So when we do g of f of 6, we're now going to plug in 35 because that's what f of 6 is equal to. So we're going to have g of 35. 5. And g of 35 is equal to, plugging 35 in for n, negative 35 plus 5. And that's going to be a negative 30. So negative 30 is our solution in number 4. G of f of 6, we evaluate f of 6, and then plug that value in for the n in our function g of n. And just to reiterate, this symbol is of. So g of f. Do not confuse this with the dot for multiplication. An open circle means of, so we're evaluating f of 6 and then g. Now moving on to number 5, we have g times f of negative 4. So we're going to take g of x and multiply that to f of x, so we'll have x plus 2 times x cubed minus 2x. And we can either multiply this out or go ahead and plug in negative 4 and solve. As opposed to plugging in negative 4, I'll multiply these two functions together and then plug in negative 4 for x. So I'm going to FOIL. First, outside, inside, last. X times x cubed is x to the 4th, and then I'm going to be adding that to x times 2x, but remember that's subtracted, so that's going to be negative 2x squared. And then I'll have 2 times x cubed, so adding that to 2x cubed, and then 2 times negative 2x is negative 4x, or subtracting 4x. I can't simplify this any further, so now I'll plug in negative 4 and solve. So we'll have negative 4 to the 4th plus negative 2 times negative 4 squared plus 2 times negative 4 to the 3rd minus 4 times negative 4. So that's going to be a positive 256 plus negative 2 times negative 4 squared is going to be negative 32 plus 2 times negative 4 to the 3rd is going to be a negative 128. And then I'll be subtracting 4 times negative 4, but that's going to be a negative, and subtracting a negative is the same as adding a positive, so I'll add positive 16 to that. 256 plus negative 32 plus negative 128 plus 16 equals a positive 112. So 112 is my solution in number 5. However, if we were to plug in negative 4 at the start, I want to show you that that is going to be equivalent. So as opposed to FOILing, I'll now plug in negative 4. Negative 4 plus 2 times negative 4 cubed minus 2 times negative 4. Negative 4 plus 2 is going to be a negative 2. So negative 2 is going to be multiplied to negative 4 cubed, which is negative 64, minus 2 times negative 4, which will be minus a negative 8, or plus a positive 8. So we'll have negative 2 times negative 64 plus 8 is a negative 56, and negative 2 times negative 56 is indeed a positive 112. So you can see that either way, we will get 112 as our solution. Let's move on to number 6. For number 6, we're going to be adding our functions, g of x plus h of x, and then we're going to plug negative 3 in for each of those. So g of x is x squared plus 2, and we're going to add that to h of x, which is 3x minus 2. Now, I'll go ahead and plug in negative 3. So we'll have negative 3 squared plus 2 plus 3 times negative 3 minus 2. 2 minus 2 is 0. Negative 3 squared is a positive 9, plus 3 times negative 3 is a negative 9. 9 plus negative 9 is 0. So 0 is my solution in number 6. Now on to number 7. For number 7, I'm finding h over g of x. H over g. So negative x plus 5 over negative 3x minus 2, and I'm plugging in x for x. But since my variable is already x, that's not going to change. So negative x plus 5 over negative 3x minus 2 is my solution in number 7. Now on to number 8. Now for 8, I'm plugging in x for g of x and h of x. So I'm just going to write the function g of x and subtract h of x and simplify. So g of x is 4x minus 2, and then I'm going to be subtracting h of x, which is x squared minus 5x. Now because I'm subtracting that entire function, we can think of this as distributing that negative. So I'll have 4x minus 2 minus x squared minus a 5x that's subtracted, so minus a negative, that will be plus a 5x. Now I'll combine my like terms, which is 4x and 5x, and then simplify. Rewriting this so that my highest degree is towards the left and my constants towards the right. So I'll start with negative x squared, then I'll add 4x plus 5x, which is 9x, and then I'll subtract 2. So in number 8, negative x squared plus 9x minus 2 is my solution. Now on to number 9. In number 9, we're adding the functions f and g together and then evaluating that at x. So essentially we have f of x plus g of x. So f of x is 2x plus 5 and g of x is 2x plus 3. So adding 2x plus 5 to 2x plus 3 and then combining my like terms, 2x with 2x and 5 with 3. 2x plus 2x is 4x and 5 plus 3 is 8. So 4x plus 8 is my solution in number 9 because I'm taking x and plugging x in for x, which is what my functions were already in terms of. Now time for number 10. In number 10, I'm multiplying h and g together and evaluating that at t. So h of t times g of t, essentially. So 2t minus will get multiplied to 4t plus 4. And I'm going to need to FOIL. First, outside, inside, last. FOILing and then simplifying. 2t times 4t, 2 times 4 is 8, and t times t is t squared. Then I'm going to be adding that to 2t times 4, which is 8t, and then I'm going to be adding that to negative 2 times 4t, which is negative 8t, and then adding that to negative 2 times 4, which is negative 8. Now when I combine my like terms, 8t and negative 8t cancel each other out. So I'll have 8t squared minus 8 as my solution for h times g of t. Now on to number 11. For number 11, I'm evaluating g of t and then dividing it by f of t. But I already have function g and function f in terms of t. So I'm simply going to have g of t over f of t, which is equal to t squared minus 2 over 4t plus 4. That's my solution for number 11. Now in number 12, they're switching it up a bit. I'm going to evaluate h of n, which I have h already in terms of n, so 2n plus 1, but then I'm going to subtract 5 times g of n. So I'm going to subtract 5 times g of n, and g of n is n minus 2. So I'm going to need to distribute this 5 before I can subtract. So I'll have 2n plus 1 minus 5 times n is minus 5n minus 5 times negative 2, which will be plus a positive 10 since both the 5 and 2 were subtracted. Now I'll combine my like terms, 2n with 5n and 1 with 10. 2n minus 5n is negative 3n, and 1 plus 10 is a positive 11. So negative 3n plus 11 is my solution in number 12. Moving on, let's go over 13. For number 13, it asks to find negative 4 times g plus 5 times h of negative 2n. So I'll do negative 4 times g of negative 2n, and then I'll add 5 times h of negative 2n. Another way I can evaluate this is to multiply negative 4 to g of n, and then multiply 5 to h of n, and then plug in negative 2n for the n's once I multiply and add those together. Here, I'm just plugging in negative 2n for n at the start. So we'll have negative 4 times g of negative 2n, which will be 3 times negative 2n plus 1. And then I'll add that to 5 times h of negative 2n, which h of negative 2n is 2 times negative 2n minus 3. So you can see what I've done is I've taken g of n, but plugged negative 2n for n, and then I've taken h of n and plugged negative 2n in for the variable n, and I still need to do my multiplication of those functions, but I'm going to simplify within my parentheses first. So I'll get negative 4 times 3 times negative 2n is negative 6n plus 1, and I'm going to be adding that to 5 times 2 times negative 2n is negative 4n minus 3. Now I'll distribute my negative 4 to negative 6n and 1, and I'll distribute my 5 to negative 4n and 3. So this is essentially g of negative 2n, and this is h of negative 2n. But I need to multiply my function g by negative 4 and my function h by 5, which I'm doing in this step. So negative 4 times negative 6 is a positive 24n plus negative 4 times 1, which is plus the negative 4, and then I'm going to add 5 times negative 4n, which is negative 20n, and then I'm going to add 5 times negative 3, which is negative 15. Now I'll combine my like terms, 24n with negative 20n, and negative 4 with negative 15. So for number 13, my final solution is 24n plus negative 20n is a positive 4n, and then I'm going to be adding negative 4 plus negative 15, which is a negative 19, but as opposed to writing it as adding a negative 19, I'll subtract the positive 19. So for number 13, I have 4n minus 19 as my solution. Let's move on to number 14. In number 14, you can see that I have h of g of 4 plus n. So I'm going to do h of g of 4 plus n. And I like writing it this way, so I know that I need to evaluate what's in the parentheses first. So I'm going to plug 4 plus n into the function of g. So I'll have h of g of 4 plus n, which g of 4 plus n is 4 times 4 plus n minus 2. So that's going to be h of 4 times 4 is 16 plus 4 times n is 4n minus 2. So that's going to be h of 16 minus 2 is 14, so h of 14 plus 4n. Now I'll plug 14 plus 4n in for my variable for h of n. So my function h of 14 plus 4n is going to be 3 times 14 plus 4n minus 1. So you can see here is 14 plus 4n, and I plug that in for my variable. So 3 times my quantity minus 1. Now I'll distribute this 3 and simplify to solve. 3 times 14 is 42 plus 3 times 4n is 12n, and I'll be subtracting 1. So combining my like terms will be combining 42 and taking away 1. So 12n plus 41 is equal to h of g of 4 plus n. Now on to number 15. In number 15, I'm going to be subtracting f from g. So I'll do g of t minus f of t. However, I'm going to plug in t over 2 for the t's in my functions. So g of t over 2 will be 4 times t over 2 plus 4, and I'll be subtracting f of t over 2, which is t over 2 squared plus 2 times t over 2. Now I'm going to simplify. 4 times t over 2, 4 divided by 2 is 2, so that will give me 2t plus 4 minus t over 2 squared is t squared over 4, distributing that exponent to both the numerator and the denominator. And then if I'm subtracting each of these terms, I also need to subtract 2 times t over 2, which is simply t, because 2 divided by 2 is 1, and 1 times t is t. So I'm going to quickly combine my like terms, 2t and t. 2t minus t is going to be a positive 1t, or simply t, and I'll be adding 4 and then subtracting t squared over 4. Now, in order to completely simplify this, we're going to need to write these all with a common denominator of 4. So, multiplying t to 4 over 4, that's t times 4 over 4, t times 1, plus 4 times 4 over 4, and I'll just rewrite t squared over 4. T times 4 over 4 is 4t over 4. 4 times 4 over 4 is 16 over 4, and I'll be subtracting t squared over 4. Now, because they have a common denominator, I'll be able to add them all together over the same denominator. So 4t plus 16 minus t squared all over 4 is my solution in number 15. Let's move on to number 16. In number 16, I'm adding the functions together of the opposite of t. So g of negative t will be 4 times negative t minus 3, and I'll add that to f of negative t, which is negative t cubed minus 2. So that's going to be negative 4t, and then I'll combine minus 3 and minus 2 to be minus 5, and then I'll add that to negative t cubed. So just reordering this, negative t cubed minus 4t minus 5 is my solution in number 16. Now on to our next section. For the next section, it says find f and g so that h of x, that's what we're given, is equal to f of g of x. Neither function may be the identity function f of x equals x, because if that was the case, these problems would be too simple. So let's get started with number 17. In number 17, it tells us that h of x, remember h of x is f of g of x, that's equal to 5 over x squared plus 1. So we're plugging some function value in for our function of f. And I think the easiest way is to work starting from our function of f. So f of x can equal, well, let's have it be 5 over x plus 1. And if f of x is 5 over x plus 1, how do we go from x to x squared? That means that g of x will need to be x squared. So then, when we did h of x, or f of g of x, we take x squared and plug that in for x. So we have 5 over x squared plus 1, which is what we want. So here are our two functions in number 17. Let's move on to number 18. Remember, h of x is f of g of x. So let's figure out what f of x is, and then g of x. Well, h of x is the square root of x plus 1 squared. So if we made this one variable x, so if f of x equaled x squared, then g of x would be what was within those parentheses. So g of x would be the square root of x plus 1. And you can see square root of x plus 1 plugged in for x would be the square root of x plus 1 squared. And that's our solution in number 18. So these problems are all about finding the simplest function that you can plug in to get h of x. So let's continue on to number 19. Now in number 19, remember, again, f of g of x. We're solving for f of x and we're solving for g of x. So let's say that f of x is the square root of x plus 1. If f of x is the square root of x plus 1, because remember we don't want to have the identity function, so we don't want something like x plus 1. If we made f of x the square root of x plus 1, what would g of x have to be? G of x would have to be what's within that radical, which is 5x plus 1. So f of x is the square root of x plus 1, and g of x is 5x plus 1. So f of g of x would be the square root of 5x plus 1 plus 1. Now we're going to move on to number 20. So we're going to find f of x and we're going to find g of x. Let's say we made f of x 3 to the x. That means that g of x would have to be the square root of x plus 1. So if we were to take the square root of x plus 1 and plugged it in for x and f of x, we would get 3 to the square root of x plus 1. That is our solution in number 20. Now on to number 21. For number 21, h of x equals the square root of x plus 3 squared. So let's say we made the square root of x plus 3 our function g of x. Then we could take that square root of x plus 3 and plug it in for f of x, which would just be x squared. Taking the square root of x plus 3 and plugging it in for x would give us the square root of x plus 3 squared. And then lastly on this worksheet, number 22. Let's say that g of x was x squared. If we had g of x be x squared, if we were to plug x squared in to f of x would need to be 4 over the variable x plus 2. That way, when we plugged g of x in for x, we would plug in x squared in for x to have 4 over x squared plus 2. And that's our final solution on this free pre-calculus KutaSoftware website worksheet. If you have any questions, feel free to leave them in the comments below. And, as always, like, subscribe, and share.